All right, I want to go through a scenario that's been presented on the discussion board of when is a routing protocol required, right here. Answer A was between two different networks. Answer B was between two routers. I've got a sample network set up here. I just mocked this up quick in Packet Tracer for this demonstration. I want to go over a couple things about routers. For one, routers route without any routing protocol at all. That's why they call them routers. If there are interfaces on a router that are directly connected and they have IP addresses on them, that router knows how to route between those interfaces. That's the first way routers learn routes, is when directly connected. The second way would be statically configured routes. Usually that's going to be a default route or a route to an extranet, which is a partner company that you're working with, or somebody where you want the traffic to take a particular route rather than your default route. Thirdly, they learn with routing protocols. So what I'm going to do is I'm going to show you on this edge router, and all these addresses are already pre-configured. This edge router would symbolize the connection between your home network and the internet, or maybe a small business and the internet. If it's a small business, you might have some sub-interfaces on it, which I have configured on here as a router on a stick. I've got VLAN 1 and VLAN 2. Probably wouldn't use those in real life, but that's what I'm using. 192.168.1 on VLAN 1 and 192.168.2 on VLAN 2. PCs are already pre-configured. And what I'd like to do is just show you the configuration on those. ipconfig all. I've got a connection for DNS with 8888, which is Google. I've got a default route gateway configured, which is the sub interface on edge 1 or edge up here. And I've got the IP addresses configured. Same thing on this other PC over here, so that you can see that 192.168.2, 2.1 is the gateway, 8888 is the DNS. Over here on PC 2, which is a remote network, I also have 8888, my default gateway, and the PC's got the 10th address just like the other three. Edge router will know about the routes that are directly connected and any statically configured routes. So let me do a show IP route, and you'll see that on this router, there is a gateway of last resort, which is this static route down here. Basically, hey, any unknown traffic, for instance, the 8888, send it out to the internet. The internet will know how to get there. There will be routing protocols out in the internet, but we're not going to have any on the edge router right now. The directly connected interfaces are shown right here in the routing table. There's the one that goes to the internet. There's this link going across here, and then my two sub interfaces. Let's go to PC 1. Let's see if we can ping the internet. Let's ping 8888. Notice I'm successful. No routing protocol in use. Let me ping google.com. I can ping that. Let me ping my favorite, certified and qualified.com, which is a site we're working on developing. Notice I can ping that. Those are out on this internet. No routing protocols got me there. Let me ping over to this PC 0. Are we going to be able to get there? 192.168.1.10. Remember, routers know how to route between directly connected interfaces, and I'm successful. Let's go back to Edge. Let's do a show IP protocol, just so you'll know for sure, hey, there is no routing protocol configured. That's amazing. Let's come over to this other link here. Now this one, I'll try to ping 8888. And notice we get a destination host unreachable message from the internal R1 router right up here. It doesn't know how to get to the destination, so it's giving me a destination unreachable message. This particular router, I will let you know, has directly connected routes and no others. No default route is yet configured. However, I did pre-configure OSPF on this router so that I could save a little bit of time. Gave it a router ID of 1111. I used a network statement that will include all addresses directly connected into the routing process. And notice I've got no neighbor, only myself. From here, remember I was unable to ping Google? Bummer. Let's go back over to Edge and let's config T Let's do a router OSPF1. Let's do individual. I'm going to do a router ID first, 2222. And let's do a network statement, one for each interface. Well, what are my interfaces? Well, we can do a do show protocol, which is a great way to get the interfaces. And you'll see that I've got 4 of them, the 10, the 2 sub interfaces, and the one going out to the internet. I am going to configure these 3. I am not going to add the internet facing router into my process. And so, but I'm going to share it using the default information originate command. So I'm going to do a network 10.0.0.1. I'm going to use the Cisco best practice of putting quad 0 on there. So only that router will go in the process. I'm going to do a network 192.168.1.1. Also quad 0, area 0. And then I'm going to do 192.168. Oh, look at that. I got a neighbor. 2.1. Okay, that one went in there as well. So now, finally, we're going to do the default information originate command. That command will share this previously configured default route right here. It's going to share with my neighbor. So let's go ahead and do that command. And then let's go over to internal R1. Notice that I have a neighbor. I can do a show IP OSPF neighbor. You'll see I've got a neighbor there. Just so you can see that whole thing on one line. And then let's go back to our command, show IP protocol. Notice I am getting routes from my neighbor. And there we go. Look at that. We've got a routes learned with OSPF and the default routes. You know what I didn't do over here? I did that command the same way twice because I got interrupted in typing. So let me correct that. Go back over to this router. And in a moment, we'll see that other router come just on this packet tracer. We can fast forward to try and speed this up a little bit. Now we've got both 192 routes on there. All right, now we come back to PC0, ping 8888. We're successful. Our routing protocol has shared the routes between the 2 routers. Let's do a ping Google to test our DNS. It's working. Let's ping certified and qualified. And we're able to do that. So everything seems to be working. Let's see if I can ping these 2 PCs over here. Ping 192.168.1.10. And we're successful. And let's ping 2.10. And we're successful with that. So what we've seen here and demonstrated is, 1, how routers learn routes. Directly connected with statically configured routes. We were able to ping between different networks without using a routing protocol, because this router knows how to route between directly connected interfaces without using a routing protocol. The purpose of the routing protocol is to share routes between networks. Share this route way over here, the 172.16. Share that route with Edge, so Edge will know how to get there. Share the 192.168.1 and the 192.168.2. Share that with the internal R1 so that it knows how to get to these sub interfaces. And we also shared the default routes right here where we learned our default gateway. So in my mind, it answers the question, when is a routing protocol required? Well, if we're routing between 2 different networks and they're remote, we would have to have some way of getting there. But between 2 routers is when we use a routing protocol. We don't need a routing protocol on a single router, as we've seen. And actually, truth be told, we don't even need a routing protocol ever if we want to take upon the task of setting up static routes on every router in the world so that they would know how to get to every other router, which would be sheer madness. So that's why we use routing protocols. We use BGP, ISIS out on the internet, and internally, normally we're going to use OSPF or EIGRP. And I hope that helps you guys understand this a little bit so that you'll know exactly what's going on here. My name's Bryan McGann, and I appreciate your time. Hope this helped.